figure out your average Chuck-a-Luck winnings. Your average Chuck-a-Luck winnings. Now, do you remember how to calculate a weighted average manually?
Times whatever there is by whatever you're gonna get. Times something like
No,
that.
you got it, Randall. It's perfect. It's been a while since we did one of these. But back in the day, the formula, if you will, that we used, the average formula, we took each data value, multiplied it by its frequency. Remember doing that? And then we added all those up. And then we divided by how many occurrences we saw. Now, it's been a long time since we did this. It's been like 4 weeks. You've already flushed this out. You flushed this out of your into your long-term memory, and it's sitting back there collecting dust. And that's okay. We've been using the TI ever since. TI ever since. All we got to do now is adjust this. Oh, some of F's, not just F. Some of F's. My apologies. Catch me. Catch my heart. Wake up, brother. All we got to do now is adjust the notation for our current notation. X is still X. We're still calling X the data. The data are -1, 0, 1, and 9. We're still golden there. What are we now calling the frequencies? Yes, the probabilities. So we're going to multiply each data point by its probability. And now here comes the best part. Summing up the frequencies is like summing up the probabilities. But what do the probabilities always sum to? No, what are the probabilities? Thank you, Faith, for the whole average is going to be negative. What is this column sum to? 1. Yeah. That was one of the properties we learned on Monday. Was that if you have, think about it this way, less mathematical. If you take 3 dice, 3 dice, I'm betting on 5, come on 5, maybe get some new shoes. How many 5s am I going to get?
I hope you get all 5.
How many 5s am I going to get? Tell me.
1.
0 or 1 or 2 or 3. 100% of the time, I'm going to get between 0 and 3 5s, yes?
Yes.
Which means 100% of the time, this has to represent every possibility. So that means I don't have to write anything. I'm just done with x times p of x. Add them up and you're done. Go, Randall.
Does that mean Yahtzee's bullcrap?
No, it means Yahtzee's fun. I got 2 4s and a 2. I should have bet on 4s. No, Yahtzee's great. It's 5 dice. 6 to the 5th power, even better. But
so unlikely.
Yahtzee's more like poker. Who's played Yahtzee?
Oh, I love Yahtzee.
It's not as unlikely as you would think, because it throws some strategy in. What are you going for, right? When you roll the dice, which dice are you then going to re-roll on your 1 or 2 extra shots you get to re-roll certain dice? That's what makes it. I've actually thought about using Yahtzee in this class, but it would take like 3 weeks to really get into the game. Oh, Yahtzee's great because it allows you to re-roll, which means the probabilities aren't as static as this is not like to say, take the bird nest, spin it. Oh look, I got a 5 and 2 3s. Let me keep the 5 and re-roll the 2 3s. Obviously these would change, wouldn't they? Much to your advantage. Much to your advantage because it's at least 0 added, if not something positive. That's why I like Yahtzee. It's fun. It's fun. So anyway, well, I know, but it's not rigged. It's not rigged. It's not rigged. Let's do it. Let's do it. Let's calculate this for the average winnings in Chuck-a-Luck. So all we've got to do is take each payoff and multiply it by its probability. Okay? So the first payoff is -$1. The probability of that, 0.5773. Which is -0.5773. I want to come to what that means in a second. The reason I like doing this one manually is I like talking about what each individual piece of the sum is actually doing for you over time. Over time. Okay, here we go. Plus sum. So plus $0 times that. So, Taryn, yes, we're keeping them playing by giving them their $1 back, hiding the fact that they're actually not profiting anything. So psychometrically, we're getting that Pavlovian bell ring, but with no saliva, so to speak, I guess.
It might be saliva.
Might be saliva. Might be saliva.
You can't say that with any certainty.
I can't say with any certainty. Hey, now here comes the positives. $1 happens 6.77% of the time. Good so far? And then the big payout, the $9 profit happens 0.0037. So 0.37%. Which if you think about it, this is roughly 100 times less frequent than this. Think about it that way. For every 100 times this happens, on average, that happens once. So for every 100 times you break even, you're going to get that $9, one out of every one of those hundreds. And it's like, okay, now I'm starting to not ever want to go to Vegas again. I'm not saying that. I'm just hoping you understand that you will not walk out of there with more than you walked in with, on average. Yes.
More likely to lose.
Good, good, Scott. Now, these are the probabilities matched with the amounts. Vote. Break or finish this? Break. Shit, tie. We got a tie now. We got to break and a finish. Break or finish?
Finish.
Break, break, break. Let's finish when you come back.
Dang it.
People on what, 3/7?
This is the problem with the American voting system.